Vanakkam. Today we are going to see a problem based on continuous functions. Find all the points of discontinuity of the greatest integer function defined by f of x equal to close x, where close x denotes the greatest integer less than or equal to x. This is what the problem. See here, the close x is equal to the greatest integer less than or equal to x. The meaning is, if you are taking minus 1, the greatest integer less than minus 1 is minus 2. If you take a value less than minus 1, the greatest value less than minus 1 is minus 2. If you take 0, the greatest value less than 0 is minus 1. If you take any value less than 0, it is also minus 1. So, here minus 1, 0, 1, 2 are integers. Less than minus 1 means values less than minus 1 which are non-integers. So less than 0 means value less than 0 which are non-integers but greater than minus 1. The meaning is this. So we are going to plot the function. See here, let me take x is equal to minus 1. What is x is equal to minus 1? We have to draw. So x is equal to minus 1. This is the point. What about the function value? The function value is minus 2. This is the function value we got for x is equal to minus 1. So what about the value less than minus 1? You see here, the values less than minus 1 are also, the function value is minus 2, the same function. It remains the same for f of x value. And see here, it won't touch minus 2, because if it touches 2, the value will be, what is floor of 2? It will be greatest integer less than 2, it will be go minus 3, minus 2, sorry, floor of minus 2 will be minus 3. Therefore, it won't touch minus 2. So from minus 1 to 2, the graph will be minus 2. The function value will be minus 2. Similarly, if you take x is equal to 0, it will take minus 1. Okay, from 0 to minus 1, it won't touch minus 1. So it will take minus 1 value. Similarly, if we take x is equal to 1, from 1 to less than 1, which is greater than, it won't touch 0, but up to this it will take the values 0. Function value will be 0. See, 0. Similarly, for 2 and less than 2, which is not equal to 1, the function value will be 1. Clear? This is the graph of the function. So it is very clear that the function is discontinuous at the integer values. See here, at the integer value it is getting discontinuous. From 1 to less than 1, it is 0, but at the point next to integer 0, it got minus 1. Similarly, 0 to 0 equal, at the point of minus 1, it is minus 2. So if you see that the discontinuity occurs in the integers, but for the non-integer values, the function is continuous. See here, we can draw this without lifting our hand. Therefore, for non-integers, the values lies between 1 and 2, the function is continuous. but at 1 the function is discontinuous. So let me prove this theoretically. So solution, let C be any number, then two cases arise. C is an integer or C may be an non-integer. Non-integer. Okay. Right. So let me see the case. What about if C is integer and what about if C is non-integer? So case 1, if C is an integer, so what about limit extends to C f of x? We have to check whether it is equal to f of C or not, right? So to check the limits, we have to go for left hand side limit. Limit x tends to C minus, that is a value slightly less than C. What is a value slightly less than C? For example, a value slightly less than 1. See, like slightly less than 1, the function value is 0. A value slightly less than 2, the function value is 1. Therefore, for the value slightly less than C, the function value will be C minus 1. Okay. What about right hand side limit? For the value slightly greater than C, for the value slightly greater than C plus, what about the close x value? Greater than C means, see here, for the value greater than 1, okay, for the value greater than 1 it is 1, less than 1 it is 0, equal to 1 it is 0. If it is greater than 1, then it will take 1. Less than, what is the meaning of less than 2? Greater than 1. Clear? Both are same. Therefore, for the values greater than C, the value remains the same, but see here LHL, left hand side limit, not equal to right hand side limit. Therefore, the function f of x is not continuous for integers. Clear? I already told that at the integer function is getting discontinuous. Case 2. If C is an non-integer, C is a non-integer, okay, so what about limit x tends to C f of x? This is limit x tends to C floor x. For non-integers, if you see, it will get the same value, less than 0. Less than 0 means, see, it remains the floor of the integer, that is greatest value less than that integer. Therefore, is nothing but we can write it simply, which is equal to floor of C. Now, what about f of C? F of C is simply the close bracket of C. Therefore, limit x tends to C, f of x is equal to f of C. Therefore, the function is, therefore the function is continuous at non-integers. So a very simple problem based on continuity. Functions. Of continuous functions. So f of x is equal to lambda is a constant function and g of x is another continuous function. Their product lambda into g of x is also continuous at x is equal to